I'm Anil Kumar sharing with you a very interesting question on vectors application. The question here is explain how you can find projection of side of a square on one of its diagonal. You can always pause the video, answer the question, and look into my suggestions. Well, let's sketch a square, and for simplicity, what I'm going to take here is a square along x and y axis, right? So this is my x-axis, this is y-axis. And let's say we take a square of 1 unit side length, right? So this becomes, let's say, the base of the square, and let me say this is I, right? A direction in x direction and magnitude 1, and similarly the other side of this square will be j, right? Normally I and j are unit vectors. So the sides are along x and y, and therefore we can kind of complete this square, and the diagonal means line joining the opposite end, that is from here to there, right? That's the diagonal. Now what are the coordinates of this point? So coordinates of this point is 1, 1, correct? So let's read the question once again. It says explain how you can find projection of side of a square on one of its diagonal. So let's consider the side to be OA, and the projection of this OA is going to be kind of like this, right? Is it okay? Making 90 degrees angle. So the projection is from here to there, right? So this, let's say this is going to be the midpoint also in a square. So OM is going to be the projection. So that's the projection OM. So as you can see here in the diagram, OM is the projection of side OA on diagonal. Let me call this point as, let's say this is B and this is C, right? On diagonal OC. Is it okay? So that is how we can actually reframe our question. I hope that's absolutely clear, right? Now based on this, I think it's simpler to answer. You can now pause the video and answer the question, right? Okay. Now what is this angle? This angle has to be 45 degrees, correct? Now in a square, diagonals bisect at right angles, right? Therefore that is 45 degrees. Now we can see the projection of OA on OC is equal to dot product of OA, right? We can say OA dot OC divided by the magnitude of OC, right? The magnitude of OC square. Or you could also write this as magnitude of OC times the vector OC over magnitude, that is a unit vector in this direction, right? So that's the formula which you can use, correct? Now what is OA? This vector OA is 1, 0, right? This vector is 1, 0, so we could write this as 1, 0 dot, this vector is 1, 1 over The magnitude of OC is square root of 1 square plus 1 square times, we have 1, 1, right? Over magnitude of 1 square plus 1 square. Is it okay? So that becomes the projection of OA on OC. And that gives you 1 times 1 as 1 plus 0 divided by 1 square plus 1 square, 1 plus 1 is 2, square root of 2, times the vector 1, 1 over square root of 2, right? And this is equals to 1 over 2, 1, 1. Or we could write this answer as the vector half, half. Is it okay? So that becomes the projection of OA on OC. If you find projection of OP on OC, that is also going to be the same since this angle is 45 degrees, right? Note. Projection of OB on OC is also going to be equal to the same, right? Perfect. So that is how you should do this type of question. I'm Anil Kumar and I hope that helps. Thank you and all the best.